For as long as our planet has existed, the Earth has been turning. A steady rotation that gives us day and night, a rhythm so constant we rarely think about it. But this rotation is not perfect, it is not fixed, and it isn't permanent. Every century the Earth spins just a little slower. A small change measured in milliseconds, too small to feel, too quiet to notice. But it is happening, and it has been happening for billions of years. So what does it mean when the planet beneath us gradually slows its turn? To understand the change, we have to understand the motion. Earth's rotation is simply the speed at which our planet turns around its axis. Right now, one full rotation takes about 24 hours, but the number isn't exact. When scientists measure the length of a day with atomic clocks, they see tiny delays, tiny differences. The days are getting longer, just a little bit, about 1.7 milliseconds every 100 years. It sounds insignificant, but in astronomy and geophysics, even the smallest shifts can reshape entire systems. So why is this happening? The answer lies in an invisible tug-of-war between Earth and the Moon. As the Moon orbits our planet, its gravity pulls on Earth's oceans, creating tides. But tides aren't perfectly aligned with the Moon, because Earth spins faster than the Moon orbits. The bulge of water is always slightly ahead, and that bulge acts like a brake. As the ocean is pulled by the Moon, Earth loses a tiny amount of rotational energy. This process is called tidal friction. Part of the lost energy transfers to the Moon, pushing it farther away, which is why the Moon is slowly drifting outward and Earth is slowly slowing down. Two motions, connected. Both almost silent. This pattern isn't just theory, we can measure it. Ancient eclipse records show that days were shorter thousands of years ago. Clocks created centuries apart no longer match perfectly. The difference is small but consistent. Modern techniques provide even more precision. Laser ranging to the Moon, GPS timing, and interferometry that measures Earth's rotation against distant quasars. All of these systems tell the same story. Earth is spinning slower, and the change is real. In our daily lives, this slowdown means almost nothing. You won't notice a longer day, nor will the seasons shift in any meaningful way. The most direct effect is on timekeeping. Because Earth's rotation isn't perfectly stable, scientists occasionally add a leap second to keep our clocks aligned with the planet. That's it, no dramatic events, no sudden changes. Just the planet adjusting itself, 1 millisecond at a time. But small changes become powerful over long timescales. As Earth slows down, the tides change too. Tidal forces weaken. The shape and timing of ocean currents adjust. Energy in the ocean atmosphere system redistributes. None of this happens quickly. The oceans respond gradually, century by century. But over millions of years, these slight adjustments can reshape coastal systems, marine life, and the long-term climate engine of the planet. Again, not through sudden events, but through slow, continuous pressure. As Earth turns more slowly, the length of a day increases. This affects how sunlight is distributed across the planet. Longer days mean longer heating cycles. Longer nights mean more cooling. Over geological periods, this may influence global wind patterns, the strength of jet streams, the rhythm of photosynthesis, and the behavior of nocturnal and diurnal species. Life evolves around the rotation of the planet. If the rotation changes, life must adapt with it, not instantly, but across millions of years of quiet adjustment. Project the trend far into the future, and Earth becomes noticeably different. Hundreds of millions of years from now, days could last 25 hours, then 26, and eventually beyond. Weather systems would move slower. Global winds would shift. The rhythm of storms and seasons would change. And eventually, in a distant future, Earth could turn slow enough that the Moon's influence alters the stability of the entire system. Not within any human timescale. Not even within the lifespan of our species, but in the scale of planets. This slow turn matters. The slowdown isn't perfectly steady. Earth's rotation also fluctuates because of melting ice sheets, shifts in ocean mass, movements in the mantle and core, and changes in atmospheric pressure. Earth is not a rigid machine. It is a dynamic system of moving layers, fluids, and forces, each contributing tiny shifts to how fast it spins. So while the long-term trend is clear, the short-term variations are complex. Rotation is a record of everything Earth carries: air, water, rock, and history. There will be no single day when Earth suddenly feels different. No moment when the world stops, shakes, or slows in an instant. The change is too small to notice, too steady to feel. But it is there, a planet turning a little more slowly with each passing century. A reminder that even something as constant as day and night is still evolving. In science, the biggest changes rarely arrive as events. They arrive as trends, quiet ones, drifting forward, 1 millisecond at a time.